Astrobotic was created to go after the Google Lunar X Prize, a $20 million award for the first commercial robotic expedition to the surface of the moon. But we have a broader agenda to serve space agencies by delivering payloads, the media and marketing industries by giving people access to contests and promotions related to going to the moon. And we want to do this repeatedly, so access to the lunar frontier will come every year rather than every few decades. There is a global rush to the moon now, led by China and India and the United States through NASA, as well as the Google Lunar X Prize competition with almost 30 separate teams competing. We are in the position of we want to beat all the other Google teams, but we also want to be soon enough, quick enough to the lunar surface that we can be of service to all the national space programs.
Launching on a Falcon 9 is the most significant event that the spacecraft will undergo during the entire mission. It will see between 7 and 8 Gs of downforce, all the while being shaken as if it's in an earthquake. Simulation plays a key role at Astrobotic because you can't ever test flying in space. It's something that you just can't do here on Earth. So you have to simulate that environment, the thermal case, the structural case, all of those things combined, because there is no way to test it on Earth. Well, ANSYS is best in class, best in the world at what they do, and they offer a complete suite of analysis tools that really enable analyzing basically the whole mission end to end, from the thermal, structural, maybe even some of the power cases, all the way through. ANSYS enabled us to analyze multiple tens of configurations at once and take a look at them and figure out which one is best optimized for our case and our solution. ANSYS showed us that our spacecraft structure, which is primarily aluminum, was stiff enough to survive launch, and that's the structure that we're going forward with and building.
The value of using simulation software like ANSYS is that you're able to get quick turnarounds and you're able to optimize everything that you're doing as far as structural design. From the very beginning, we were getting into ANSYS, we were coming up with ideas, very quickly able to translate those ideas into code and produce results that were meaningful, so that it wasn't just our opinions that were backing our configuration choices. It was real results in a simulation environment. If we didn't have ANSYS simulation software, it'd be very difficult to accomplish anything of this nature.
For us, the value of the ANSYS software is it keeps us in the game. If we didn't have that ability to move quickly and be sure-footed about the choices that we make, a small team like ours just wouldn't be able to compete. I think we have probably the most sophisticated approach to getting to the moon using tools like ANSYS, and in our case, we're the only one that has reserved a launch vehicle. So we have the means and the methods of pulling this off.